Okay, we're going to meet a new piece of notation now. So this is it. It's ln of x. Now, it's one of the buttons that was on your calculator, so you'll be able to type this in. This is what it means. It's a particular type of log. It's one with base e. Now, e is a number that we met last week. It's an irrational number. It's about 2.7. Now, I've written it like this so you can see what it is. We will never be writing it like that. This is always the way we're going to write it, ln of x. Now, usually I will just be referring to it as log of x, because usually in the context you'll be able to work out the natural logarithm. When you want to say that it's this particular type, we call it the natural logarithm. And it's got two special properties here. So if we look at this first one, we're saying natural log of e of x. If we actually think about what that's doing, it's log base e of something. So what power do we have to take e to get to e to the x? Well, the answer by definition has to be x. So you can think of log and e as inverses of each other, just in the same way, say, like square and square root. These are things that undo with each other. If you look at this one, e to the power of log of x, that will also give us x. So if you have an e and a natural log, they will cancel out. That's the main thing that we're going to be abusing this lesson. Let's have a look at an example. So we've got e to the power of something equals 10. The goal of this is to solve for x. So we need to find the value or values that x equals. Any time that we get to a step where we've got e to the power of something equals a number, if we take log of both sides, natural log, we get this. Natural log of e to the 3x plus 1, close brackets, equals natural log of the other side. If we're doing the same thing to both sides of the equation, it should still be equal. But we know from this rule up here that if we've got natural log of e of something, they cancel out. And so we get left with that. Don't really need the brackets on the log 10 here. Right, a couple more steps. If I take away 1, log of 10 minus 1, and then I'm going to divide by 3. X equals log of 10 minus 1 all over 3. Now, this is the exact form. Sometimes it will say write your answer to 3 decimal places or 3 significant figures, that kind of thing, in which case we type that into the calculator and we'll work it out. Most of the time, we're just going to leave it as an exact form. Let's do another example. Okay, this one has a log in it, but again we had to rearrange for x. Now, just like with normal algebra, we can deal with the bits on the outside of the function first. If we think what happened to x, we multiplied it by 3, we then took away 4, we then took log of it, then we multiplied it by 2, then we took away 6, and the result was 0. It's just like number machines back at primary school. We're going to undo each of those operations in order. So starting from the outside, if we add 6, so 2 log of 3x minus 4 equals 6. We're going to divide by 2, so we get log of 3x minus 4 equals 3. Right, now we're at the step where we've got log of something equals a number. We're going to use this rule here. If we take e to the power of both sides, well, if we do the same thing to both sides of an equation, then it should still be equal. So e to the power of the left-hand side equals e to the power of the right-hand side. However, we know that these cancel. And so the left-hand side is 3x minus 4, and this side's e to the 3. Now this is just a number, because it's about like 2.7 to the power of 3, but we're going to leave it in exact form again. Unwrapping, we can add 4, so e to the 3 plus 4, and then last step, let's divide by 3. E to the 3 plus 4, all divided by, sorry, I've run out of room, divided by 3. This is exact form. Again, if we wanted to, we could type into the calculator and work it out to some decimal places. What I'd like you to have a go at are 2 examples. Here you go. 2 problems for you. Pause the video, have a go, and now go through the answers. Okay, let's have a go. So, I use red. This first one, if we divide by 2, we get e to the 1 minus x equals 5 over 2, or 2.5 if you prefer. Take log of both sides, we get 1 minus x equals log of all of that. I'm just using brackets to make it clear that it's log of the whole side there, not just log of 5 and then divided by 2. And then if I took the x to the other side, took that to the other side, I'm going to get x equals 1 minus log of 5 over 2. There are other ways to write that, because you've done some log rules, you know that that's a log of 5 minus log of 2, but this is nice and exact. Right, this one, I'm going to take e to the power of both sides, which gives me 3x squared minus 6 equals, well, e to the power of 0, anything to the power of 0 is 1. Take the 6 to the other side, 3x squared equals 6. Also, 7. Dividing by 3 is 7 over 3. And then the last step here is quadratic equation. I can take the square root. So x equals plus minus square root of 7 over 3. We got two roots there because we could take the positive and the negative square root. Right, I'm going to do another video going through some harder versions of those. Probably watch that first before you do any examples.